In this video, I'll cover the test corrections for Module 12. Okay, for the first example here, it says to solve the equation using the quadratic formula. Okay, and so here the quadratic formula is, or if I have ax squared plus bx plus c equals 0, then the solutions for x can be determined using the quadratic formula, okay, which is determined by x equals a negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Okay, so the first thing we want to do is determine the values for a, b, and c. Okay, and so here if we look at 2x squared minus x minus 6, our value for a is 2, our value for b is a negative 1, and our value for c is a negative 6. So my solutions will be determined by x equals a negative of b plus or minus the square root of b, which is negative 1 squared, minus 4 times a, which is 2, times c, which is negative 6, all divided by 2 times a, which is 2. Okay, so we want to clean this up to determine our solutions for x. We have a negative of negative 1, which will become positive 1, plus or minus the square root of negative 1 squared is a positive 1, minus 4 times 2 times negative 6. So 4 times 2 times negative 6 will give us a negative 48. And since that is minus a negative 48, this will become plus 48. Okay, so basically you have a sign here, so you'll have a minus or a plus left. When I multiply this part, I get a negative 48. So minus a negative 48 is where we get the positive 48. Okay, all over 2 times 2, which is 4. And so we want to simplify. We have x equals 1 plus or minus the square root of 49 divided by 4. And so here the square root of 49 is 7. And so we have two solutions. We have x is equal to 1 plus 7 over 4. And x is equal to 1 minus 7 over 4. Okay? And so for 1 plus 7, we get 8 fourths, which simplifies to 2. And then for 1 minus 7, we get a negative 6 fourths, which if we simplify, 6 and 4 both have a common factor of 2. So this is like negative 3 times 2, and this is like negative 2 times 2. So if I reduce it by a 2, negative 6 fourths will simplify to a negative 3 halves. Okay, and so our two solutions are 2 and a negative 3 halves. Okay, let's look at the next one. Okay, here it says to solve the equation by using the quadratic formula. And so in this case here, we'll do the same thing. The only difference in this problem, we need to make sure all terms are on one side with 0 on the opposite side. Okay, and so here, remember, if we have ax squared plus bx plus c equals 0, then we can use a quadratic formula and say that x is equal to a negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Okay, so in this case here, we need the first part. We need ax squared plus bx plus c equals 0. And so what we're going to do is rewrite this. We have 7p squared equals negative 6p plus 3. And it doesn't matter which terms you move to which side, just as long as you get 0 on the opposite side. But in this case, I'll keep the 7p on the left side, 7p squared on the left side. And so if I move the 6p over to the opposite, I'll have to add 6p to both sides. So this will become plus 6p. And since this is minus 3, I'll need to subtract 3 on both sides. And so minus 3. And so now we have 6p squared plus 6p minus 3. And we can determine our values for A, B, and C. Okay? So A is equal to 7, B is equal to 6, and C is equal to a negative 3. Okay? And so we can determine the solutions for X by using the quadratic formula. We have X equals a negative B, in which case is 6, plus or minus the square root of B squared, which will be 6 squared, minus 4 times A times C, which will be 4 times 7 times negative 3, all divided by 2 times A, which is 7. Okay, so we have a negative 6 plus or minus the square root of 6 squared is 36 minus, and we'll keep the minus, 4 times 7 times negative 3 will give us a negative 84, which becomes plus, minus a negative, all over 14. Okay, so we have X equals a negative 6 plus or minus the square root of 36 plus 84 will give us 120 divided by 14. Okay, and so what we want to do first is simplify the square root of 120. And we'll do that by writing all of the prime factors, writing out all of the prime factors of 120. So if I divide 120 by 2, I get 60. If I divide 60 by 2, I'll get 30. 30 divided by 2 will give me 15. 15 divided by 3 will give me 5. Okay, and so I'm just writing out all the prime factors for this number. And so the square root of 120 is the same thing as the square root of 2 times 2 times 2 times 3 times 5. And so since we're finding the square root, we're looking for squares. And so 2 times 2 will be 2 squared. The square root of 2 squared simplifies. It's just a single 2. Or think of it as the square root of 4 is 2. Okay, so 2 will come out. And then I have one factor of 2, one factor of 3, and one factor of 5. So that won't simplify. So we'll keep those together and multiply those back out. So we have 2 times 3, which is 6. 6 times 5, which is 30. Okay. And so the square root of 120 will be equivalent to 2 square root of 30. So we'll come back here and we have X equals negative 6 plus or minus 2 square root of 30 all over 14. Okay, and so we have two solutions here, but we can reduce this. Okay, so you can split it apart and write two solutions and reduce it, or you can reduce it all at once. I'm going to reduce it here. If I look at each term, negative 6, 2 square root of 30, and 14, all terms or values have a common factor of 2. And so here, when we simplify, we want to factor out 2 in the numerator and in the denominator. And so if I factor out a 2 from negative 6, I have a negative 3. If I factor out a 2 from 2 square root of 30, I'm left with the plus or minus square root of 30. And if I factor out a 2 from 14, I'm left with 7. Okay? And so now I can cancel the 2's, and I can say that X is equal to a negative 3 plus or minus the square root of 30, all divided by 7. Okay? And if you want to split the answers apart, you can say that X is equal to negative 3 plus the square root of 30 over 7. And X is equal to negative 3 minus the square root of 30 over 7. Okay, so either solution will be correct. Okay, If you choose to do the first solution, make sure you look for the plus or minus symbol so that you can express that that is two solutions, or that does have two solutions. Okay, let's look at the next one. Okay, for the next one, it says to graph the following quadratic function using its properties based on the graph, determine the domain and the range of the quadratic function. Okay, so for this one here, it says that g of x is equal to x squared plus 12x plus 20. In order to graph the quadratic function, the first thing we want to determine is the vertex. Okay, and so the vertex is found by the formula negative b divided by 2a to get the first coordinate of the vertex. To get the second coordinate, we'll plug in this value that negative b over 2a simplifies to into the function, finding f of negative b over 2a. Okay, and so in this case, since our function is called g instead of f of x, we'll say g of negative b over 2a. Okay, so let's do that first. Here, our value for a is equal to 1, and our value for b is equal to 12. So to determine the first coordinate of the vertex, negative b over 2a, we have a negative b, it's 12, over 2 times a, 2 times 1. So we get negative 12 over 2 times 1, which is 2, and negative 12 divided by 2 is a negative 6. So this gives us our first coordinate of our vertex. Now we need to find f of negative 6 to determine our second coordinate. Or g of negative 6. So g of negative 6 will be equal to negative 6 squared plus 12 times negative 6 plus 20. Okay, and so for the negative 6 squared, we'll get 36 plus 12 times negative 6, we'll get minus 72 plus 20. Okay, and so this will simplify to a negative 16. So our vertex, which is the first thing we want to plot within my lab, will be negative 6, negative 16. Okay. Now, finding one of the other properties, here we can determine the x-intercepts or the y-intercept. We'll do the y-intercept first. For the y-intercept, if you remember, the value of x will be equal to 0 because it crosses the y-axis. And so for that value of x, it'll always be 0 if it's along the y-axis. And so we'll evaluate our function. Since we know x is 0, we'll evaluate our function g for 0. And so if I plug in 0 here, we have x squared, which is 0 squared, plus 12 times x, which is 12 times 0, plus 20. So the y-intercept is really easy to find. It'll always just be the constant value because we'll be plugging in 0 for the x's. Okay, so we know our y-intercept is 20, or if I want to express that as the point, or it's the ordered pair 0, 20. Okay, for the x-intercept, or the x-intercepts, the x-intercepts will be where y is equal to 0. And since y is the function of x expressed as f of x or g of x in this case, we'll actually set the function g of x equal to 0 and solve for x. Okay? And so here, if my g of x is expressed here as x squared plus 12x plus 20, we'll say that that x squared plus 12x plus 20 is equal to 0. Okay? And so here, if I factor this, two numbers we multiply to get 20 that also add up to 12 will be 10 times 2. 10 times 2 is 20. 10 plus 2 will be 12. Okay? And so two numbers we multiply to get x squared are x times x. Since this is a positive 2, I know the signs are the same. And so here, since this is a positive 12, we know these are both positive values. So we have x plus 10 is equal to 0, and x plus 2 is equal to 0. If we solve these both, We'll get minus 10 on both sides for this one and get x equals a negative 10. Minus 2 on both sides of this equation to get x equals negative 2. And so our x-intercepts are negative 10 and negative 2, or they can be expressed as the ordered pair negative 10, 0, and negative 2, 0, because we know the value of y, or the value of g of x, is 0. Okay, so in order to graph the quadratic, the first thing we want to plot is the vertex. We have negative 6 falls in between the negative 8 and negative 4. Negative 16, so we have negative 6, negative 16. And then we can plot the y-intercept, which is the point 0, 20. Or we can plot an additional point of the of the x-intercept, which is negative 10, 0 or negative 2, 0. So here we see negative 10, 0 and negative 2, 0. All points are included. But in order to graph in MyLab, you only need 2 points, okay? So make sure you're plotting the vertex first, and then you can choose any other point that you want, okay? Okay, next it asks for the domain of g of x. The domain represents all possible values of x expressed by the function. So here, all possible values of x. And so in this case here, I have a quadratic function that keeps going. So as this keeps going, the graph in terms of the x-axis continues on to positive infinity, and here to negative infinity. So the domain is from negative infinity to positive infinity. Okay, so the leftmost point of the graph to the rightmost point of the graph. And if it has arrows here and it continues on indefinitely, we say that it goes to infinity. Okay, in the negative direction and also in the positive direction. Okay, for the range, this is going to be the lowest point of the graph to the highest point of the graph, or basically all possible values of y. And so if we look at this from the bottom to the top, this vertex starts at negative 16, and we say that value is included with a square bracket. And it goes up, the graph goes on indefinitely to infinity. So it goes from a negative 16 up to a positive infinity. Okay, so that will be our range of our function. Okay. Okay, let's look at the next example. Okay, for number 5, it says to determine whether the following quadratic function has a maximum or a minimum value. Then find the maximum or the minimum value and where it occurs. Okay, so anytime we're talking about the maximum or the minimum value of a quadratic function, the quadratic function is the shape of a parabola. And so if it opens downward, you'll have a maximum. And if it opens downward, then that means the value of a is negative. If it opens upward, you'll have a minimum value for the vertex or the lowest point. And so that will be if a is positive, it opens upward. Okay. So here, if we look at our function g of x, which is equal to a negative x squared minus 4x plus 3, our value of a is negative 1. So that tells us automatically that the parabola is going to open downward. And so the highest point of the graph will be the vertex. And so we'll have a maximum value. Okay. So in order to find the maximum value, we'll need to first find the vertex. From the vertex, the first coordinate, negative b over 2a, will give us where our maximum occurs. And f of negative b over 2a will give us our maximum value. Okay. And so since we already have the value of a, we can write the value of b, which is negative 4. And so we can determine our vertex from this point. So we have negative b over 2a, which will be a negative of b is negative 4 over 2 times a is negative 1. So a negative of negative 4 will be a positive 4 over 2 times negative 1 is negative 2. And so 4 divided by negative 2 is negative 2. So we know it occurs at x equals, our maximum will occur at x equals negative 2. Okay, because this is our first value or our first coordinate. Now to find f of negative b over 2a, we'll actually find f of negative 2. But in this case, our function is called g of x. So let's change that. We'll find g of negative 2. Okay. And so I'm going to move this down. G of negative 2 will be a negative of x squared. So a negative of negative 2 squared minus 4 times x. So minus 4 times negative 2 plus 3. Okay. And so we have a negative of negative 2 squared, which is 4, minus 4 times negative 2 will be a positive 8 plus 3. And so a negative 4 plus 8 is a positive 4. A positive 4 plus 3 will be 7. And so we know our vertex is negative 2, 7. But this tells us where the maximum occurs. And 7, the actual value, the y-coordinate will be the actual maximum value here. Okay. So of the vertex, this is where it occurs. The x portion, and this is the actual min or max value. Okay, let's look at the next one. Okay, here it says to solve the equation 3x squared minus 4x equal 15. Okay, so you can use one of two methods. The first method we learned was to make sure we have all terms on one side. So we'll subtract 15 on both sides. So we have 3x squared minus 4x minus 15 equals 0. And so we can take this, and we have a times c above. So 3 times negative 15 is a negative 45. And then b goes here, and that'll be negative 4. So we have negative 45. Since we have a negative product, we know we're going to multiply a negative times a positive. But for now, we'll just list all the factors of 45. And we're looking for factors that will subtract to give us a negative 4. And so here, or add to give us a negative 4 with the signs being different. Okay, so same thing. We have 3 times 15. 4, 5 times 9. And so with 5 times 9, the difference of 5 and 9 will give us 4. So we'll write 5 times 9 here. In order to get a negative 4, the 9 should be negative, the 5 should be positive. Okay? And so we can write 3x over the positive 5, and then 3x over the negative 9. And so this is simplified, 3x plus 5. But this can be reduced. If we factor out a 3, that'll become 1, and this will become negative 3. So we have x minus 3. Okay, and that will give us our two factors. Okay, so that's one method. And I'll put the factors above first. So we have 3x plus 5 times x minus 3 equals 0. Okay. Another method will be the AC method. We have 3x squared minus 4x minus 15 equals 0. But we first want to factor this. And so we have a times c, which is 3 times a negative 15, negative 45. And we still list our factors. 1 times 45, 3 times 15, 5 times 9, until we find a factor that gives us the difference of 4. Okay? And so in order to get the difference of 4, we know the 9 should be negative and the 5 should be positive. And so what that allows us to do is to factor We have 3x squared. Instead of minus 4x, we'll say plus 5x minus 9x, which is what we get in order to get the 4. Just write both factors out, or both terms out. Minus 15 equals 0. And then we factor by grouping. Okay? And so if we group the first two terms, 3x squared plus 5x, both have an x in common. So if we factor out an x, we get 3x plus 5. Here, for negative 9x and negative 15, since this is negative, we're going to factor out a negative. And they both have a common factor of 3. So if we factor out a negative 3, we'll get a positive 3x left from the negative 9x. And if we factor out a negative 3 from negative 15, we get a positive 5. Okay? And so in this case here, we can see that they both have a common factor of 3x plus 5. So we factor that out. And what's left over when we factor is x minus 3. Okay? And so in this either case, we get the same two factors. Okay? So you can use either one of those methods. Okay, so from there, we'll come above. And if we have two factors multiplied to get 0, we can say the 3x plus 5 is equal to 0, or the x minus 3 is equal to 0, and then solve both equations for x. Okay, so we want to subtract 5 on both sides, and we get 3x equals negative 5, and then divide by 3. So the first solution is x equals a negative 5/3. Here, for x minus 3 equals 0, we'll add 3 on both sides to get x equals 3. Okay, so we get a negative 5/3 and a positive 3. Okay, and notice here the order doesn't matter just as long as the signs are the same. Okay, let's look at the next one. Okay, for number 7, it says to graph the following quadratic function using its properties. Based on the graph, determine the domain and the range of the quadratic function. So this is similar to one that we just did before. Okay, so here, in order to graph, the first thing I need to determine is the vertex. Okay, and so here my vertex is determined by the formula negative b divided by 2a to get the first coordinate. And then we'll evaluate f, or in this case, g, for negative b over 2a. Okay, so if we look above here, we have that a is equal to a negative 1. Okay, and we have that b is equal to a positive 4. So negative b over 2a is equal to a negative of 4 over 2 times negative 1. So we have negative 4 divided by negative 2, which is positive 2. Okay. We want to evaluate g for negative b over 2a. So we're going to evaluate g for positive 2. Okay. So g for positive 2 will be a negative of x squared. So a negative of 2 squared plus 4 times 2 for the x plus 12. And so we have a negative of 2 squared, which is 4, plus 4 times 2, which is 8, plus 12. And so we get negative 4 plus 8 is a positive 4. A positive 4 plus 12 is a positive 16. Okay. And so our vertex will be 2, 16. Okay. And so notice here, this is 2, 16 there. Okay. And then to graph an additional point, we can determine the y-intercept or the x-intercept. In this case here, I'm going to find the y-intercept. And for the y-intercept, we know that x is equal to 0. So we'll evaluate our function g for 0 since we're replacing x with 0. Okay, so g for 0 will be a negative of 0 squared plus 4 times 0 plus 12. And so our y-intercept will be 12. And so if the y value is 12 and the x value is 0, our y-intercept is the ordered pair 0, 12. Okay, and so that will graph our function. Okay, the domain represents all values, all possible values of x. So here, if my graph extends indefinitely in the negative or in the negative x direction, it goes to negative infinity, and then it extends indefinitely to the right in the positive x direction, that goes to positive infinity. And so our domain is negative infinity to positive infinity. Okay, so the leftmost part of the graph to the rightmost part of the graph. And if it keeps getting wider and wider and wider, it goes to infinity in both directions. Okay, for the range represents all values of y, so all possible values of y of the function. So we'll start from the bottom of the graph here. Notice we have arrows, so it goes from negative infinity up to the highest point of the graph, which is at the vertex. And so from negative infinity up to a positive 16. Okay, and so that's where we get the vertex there. Okay, let's look at the last one. Here it says to solve using the quadratic formula. So we already have it in ax squared plus bx plus c equals 0 in general form. And so our values of x are determined by the quadratic formula, negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Okay, so we can say if it's in this form, then the solutions for x are determined by the quadratic formula. Okay, so here we will determine our values for a, b, and c. A is equal to 1, b is equal to negative 6, and c is equal to a negative 27. So we'll use our quadratic formula to determine x. X is equal to a negative of b, which is a negative of negative 6, plus or minus the square root of b squared, so that'll be negative 6 squared, minus 4 times a, which is 1, times c, which is negative 27, all divided by 2 times a, which is 1. Okay, so here if we simplify, we get a negative of negative 6, which is positive 6, plus or minus the square root of a negative 6 squared, which will be a positive 36, minus 4 times 1 times a negative 27. So minus 4 times 1 times a negative 27 will give us a positive 108, all divided by 2. And so here, if we add 36 plus 108, we'll get 144. So we'll get 6 plus or minus the square root of 144 all over 2. The square root of 144 is just 12. So this will be 6 plus or minus 12 divided by 2. So we get x equals 6 plus 12 divided by 2. And x equals 6 minus 12 divided by 2. Okay, so 6 plus 12 will be 18 divided by 2, and 18 divided by 2 is 9. And 6 minus 12 will be negative 6 divided by 2. Negative 6 divided by 2 is a negative 3. So we have our two solutions, x equals a 9, or x equals positive 9, and x equals a negative 3. Okay, you should be able to retake your exam now.